So in part 3, they want us to draw rough sketches to represent the following functions. They've given us the same 4 functions from before. Nature of roots in one column, so that's from part 2 above, and they would like a rough sketch. Now for the nature of roots, we can just fill in what we had from before. So I'm just going to go ahead and do that. We're just taking information from part 2 and we're filling in these 4 spaces. So here's all of that information filled in. And remember, first equation, unequal, rational, real. Second equation, unequal, irrational, real. Third equation, equal, rational, real. And the last equation was non-real. Now, they expect you to draw a rough sketch, which is not going to fit in those rows. So I'm just going to do it underneath. But to do this, I'm just going to label it 1, 2, 3, and 4, just so that when I do the sketches, we know which sketch belongs to which equation. So there are no values expected to be filled in on these sketches. It's just a rough sketch to give you an idea of what the roots should look like. First equation, our roots are unequal, they are rational, and they are real. For something like that, let's first start off with our x-axis. Now what I want you to realize is that your y-intercept here was -2. So the graph is intersecting the y-axis, which -2 I'll take somewhere there. And if we draw our graph through that point, firstly, why am I drawing an upward smiley face graph is because our a value is positive. It was +12. And here we can clearly see that our roots are unequal. They are at 2 distinct points. For equation 2, 3x squared plus 6x plus 1, that graph now cuts the y-axis at +1. If we take +1 somewhere here, our graph looks something like this, where we can, okay, I've just drawn that a bit better, where we can see that there are 2 distinct roots. Now, it's actually okay if your graph is a little more to the left or more to the right. It's fine. They're just testing you and seeing whether you understand the shape of the graph as well as what rational and unequal roots means. If we go up to equation 3, the roots are equal, rational, and real. What does it mean when we have equal roots? It means that the turning point lies on the x-axis. So there is only one root. That will look something like this. Here we can clearly see that the root lies on the x-axis. And the last one for equation 4, the roots were non-real, meaning that they do not exist. So the graph that we have is going to lie above the x-axis entirely. So if that's our x-axis and that's our y, the graph does not cut through the x-axis at all. So there are no roots. That brings us to the end of part 3.